Are you someone who are writing CI/CD pipelines like continuous integration and continuous delivery quite often, probably for infrastructure or for applications? And while doing so, you still create long-lived credentials or probably service account keys. Or you are someone who are part of a team who believe that there's something they can improve in their system from security point of view, but they do not know where to get started. Or you are someone who likes to hear someone else's tried and tested approach and then try to customize it as per your own need, as per the use case in hand. If the answer to any of these questions is yes, then I strongly believe that this talk is for you. And by the end of this talk, I hope that I'll give you enough ways to start your own security journey. Zero trust is related to security. Let's see some interesting fact about security. What you see here on the right side, some big industry names like Google Cloud, AWS, Azure, GitHub, GitLab. And when you talk to them, they always endorse that they are using latest security principles, latest protocols available in industry from security point of view. They all strongly believe that they are secure till they are not. The latest news from GitHub, it's news from May, they find out that approximately 100K users of NPM data was stolen from GitHub. That's not all. When they did root cause analysis of the problem, they find out that they were printing personal access token of the users in their logs. That's really interesting. On one hand, they are advocating they are secure. And on another hand, they are not respecting even the basic principles like not printing personal information or the sensitive data in the logs. And that leads to a very interesting conclusion about security. We are only secure till we are not breached. And that leads to another question for all of us. Were any of these systems really secure? We're going to take this question with us, and we'll see that by the end of this presentation, or by the end of this talk, if we can answer this together. My name is Amit. I'm a lead infrastructure consultant at Thoughtworks Romania. I've got around 13 years of IT experience working in different countries, India, Romania, and Germany. I'm heavily involved on infrastructure side. I'm a Terraform certified S8 and writing testable and secure infrastructure for more than 3 years. I mainly work on Google Cloud, but trying to explore other cloud infrastructures as well. And this is where I can be contacted on LinkedIn or on Medium. Security is a journey. Today, as part of this talk, I'll try to walk you through a journey which is traveled by 2 teams. It's a 12-week journey. It has its own climax also. It's like a typical Bollywood or Hollywood movie, actually. So we're gonna walk this together. So let's start. The journey starts with the team Y, and it's a happy team. It's a client team, and they believe that everything is okay. They have an infrastructure, things are working. And the only reason they believe that everything is okay because they were never breached. So for them, everything was perfect. Whenever they needed something, they requested it and they got it. They needed a service account key, they requested it, and somebody provisioned that key for them. And everything was working fine. By end of week 1, they were joined by another team. It's a team, it's my team, a team from Thoughtworks. One of the reasons why this team was hired that the team Y wanted team G to assist them on doing some infrastructure as code. But another thing that they wanted was to help them review the existing implementation from security point of view and see if everything is okay. And if that's not the case, then see how we can fix it. So that's the main objective of why these 2 teams came together. So when 2 different teams joins, we need to find some ways of working together. And that's how we started our week 2 and week 3. We started with things like hopes and fears. So we discussed what to expect and what not to expect. way of working, like, do you want to do pair programming? We said, okay, that's a good thing, let's do it. We defined the definition of ready and done, the vision of the team. We also defined what meetings we should attend and what we shouldn't. We decided the communication channels, how we're going to talk to each other, how we're going to transfer information, knowledge as part of this journey. And the last thing, we discussed our Jira workflow. We were working with Jira, and we decided how we're going to move the things from one stage to another. So by end of week 3, we have 2 teams, Team Y and Team G. They are all set to sail together. They understand the best part, that they understand their priority. They understand that they need to work on fixing the security problems. And they kind of have a rough idea on how they're going to do it. They're going to look into the current implementation and see if there are problems. They're going to prioritize them and going to fix them. That's what they think. Now, Team G wants to fix something, but in order to fix something, they need to find out what it is. So they started to figure out how to find the problem. If we need to find a problem in something, first of all, we need to understand how it works. So the week 4 and week 5, we started with some pairing, because that's what we agreed as part of our way of working. So as part of pairing, a colleague from Team Y and another colleague from Team G, they started to pair and started to working together. The main idea of this pairing was to discuss things and to exchange the knowledge so that the Team G can understand the system that Team Y had implemented. And then to see if there's some problem with the system so that they can find the problems and then start to fix them. So that's our primary focus, basically, to look into the system from security point of view and then find out if there are any security enhancement that can be done in the system. Okay, so we are pairing together. We want to understand the system. If we want to do that, we have to ask the right questions. And that's what Team G started to do. They started to ask things like, okay, you have secrets in GitHub. Why so? Why not in Google Secret Manager? How you define environments in GitHub and GCP? Things like that, some basic things which probably weren't documented in the right way. And then they started to ask the open-ended questions so that those questions or the answers to those questions can help them to understand the system. They all also wanted to ask who implemented something. That's not because they wanted to criticize somebody to how they did it. This is because they wanted to talk to this person to help them better understand the system. By end of week 5, when these teams, Team Y and Team G, they worked together, they came up with some findings and some recommendations. So in terms of finding, they realized by asking different questions and by understanding the system, they realized that we do have some security issues in the existing implementation that can be fixed. However, by just asking random questions and the kind of answers they had, they realized that they do not have structured information. It was more like asking a question and getting an answer. I asked something, you answered it, and I have it in my mind. But this information wasn't available in a structured way. Another problem that they realized that they asked some random questions, got some answers, but it wasn't sure whether the kind of analysis or the kind of information that they had till now that actually covers the entire system. Those were some random questions and the random answers only. And since the information wasn't structured, they were not sure how to define the priority or the impact and where to start from. And that's where they came up with a recommendation. The recommendation was that we understand that there's a problem, but we need a process. We need a process that can help us to put this information in a structured manner and then help us to analyze that information, to visualize the impact, and understand our security priorities. So by end of week 5, we started pretty much together. We were all excited. By end of week 3, we were all excited to sail together. But by end of week 5, we realized that we need some external help. We need somebody to help us to run a security process. In another term, we needed a security champion. And that's where I'm going to introduce you to Mr. S, our security champion. It took us approximately 1 week to find somebody who was willing to help us in this regard. In our first introduction section, we talked about what we need from this person. And that person was quite confident. Okay, I think I know what you need. Probably there's something I can help you with. And we said, okay, let's do it. Let's do it together. So by end of week 6, we were quite two smiling faces again, because we realized by the end of week 5 that we had problems. But by the end of week 6, we knew somebody could help us, and that somebody had already joined us. And that's where Mr. S introduced us to something called threat modeling, which he thinks is a probable remedy of our security issues. When we were talking to Mr. S, he was listening our conversations, and we were asking him, okay, are we secure, are we not secure, things like that. And he realized that we basically do not understand how to define security. And one of the first things that he introduced us as part of this threat modeling exercise, that's a definition that comes, let's say, with threat modeling, that the security is not about simply saying yes or no. I cannot say simply that a system is secure or not. It's more about defining an acceptance level and see whether you are within that acceptance level of the security. So you define what is your acceptance level that you can think, you can carry out the risk, and you have to live within that level. That's security. It's not about a simple answer of yes or no. And that's how we started this. He also introduced the fundamental definition of threat modeling. And the way it goes, it's more about identifying, communicating, understand, then mitigate or prevent. So first of all, we identify the problems in our system. We talk about them. We understand them a bit more deeper. And then we see if they're already there, then we're going to mitigate them. And if there's something, we can prevent them so that that's not even get into the system. Another thing that threat modeling talks about is to continuously run the exercise so that if you change something in the system going forward, or if you introduce something new, you need to make sure that you always remains within an acceptable level of risk. The way we do threat modeling is the steps that we see on the right. We define the assets for our organization. We set up the security goals, the disaster scenarios, understand a bit of architecture of our system, and then we do something called evil brainstorming. And at the end, we prioritize our problems based on impact and probability. I'm going to quickly look into some of these things so that we understand the problems of our system. So what is an asset? Asset is something that as an organization you want to prevent, and as a hacker you want to have. It could be something tangible or intangible, like your code, your infrastructure, your network, or something intangible like your reputation or performance. In our case, we list down some of the assets that we think we wanted to analyze. So like our GitHub repositories, our pipelines, secrets, service account, load balancer, and the SQL instance. Then here comes CIA. It's a CIA security goals. We defined our security goals. What we wanted to prevent confidentiality, integrity, and availability. So those are security goals that we want to make sure that we prevent. And that's when we started something called evil brainstorming. We decided that we're going to hack our system from the hacker's point of view. As part of this exercise, what you see on the left side is our assets. That's what we had in the last slide. And the possible attacks that we found out or we understood at the end of the evil brainstorming exercise. We kind of did the brainstorming and we find out how our assets can be attacked. Things like unauthorized logins. Somebody could probably get into our infrastructure and modify it or even delete it. They can log some sensitive information, elevate their own permissions to do something really drastic, update information because it's a website which publishes the price information publicly, and if somebody is going to change that, obviously that's going to be a disaster. They can even bring down some temporary unavailability for developers and some data leaks. So these are some of the attacks that we identified. And then what we did, we started putting, depending on the attacks, we started to place our assets in one of these quadrants. What falls under accept is something that we can live with. We say, okay, that's fine, that's within an acceptable risk. But what falls under mitigate has to be fixed, has to be mitigated for sure. And as part of analysis, we realized that our GitHub repositories, code and pipelines, the way they are currently configured, they falls under mitigate section, the mitigate part of the quadrant, and we have to mitigate them. By end of week 8, we had these findings in terms of our GitHub code and CI/CD pipelines. We realized that we had something called long-lived credentials. We created them, but they are never expiring. So it's like giving a key to someone and never asking them back. We realized that we do not have two-factor authentication, not good. We realized that we were using only one service account, and this service account was like a super user. It had everything you wanted it to do. And the last thing, in our case, the GitHub system had no specific identity, which means we did not have the concept of never trust, always verify. So the communication between GitHub and GCP was always being trusted, and that wasn't right. So this part of our system where a user connects to GitHub, just an example, it could be any other version control system. And then the GitHub connect to GCP, it could be any other cloud provider, but in our case, it was GitHub and GCP. So this part of the system where user connects to GitHub and the GitHub connect to GCP was something which had to be fixed because this fell into the mitigated part of our quadrant. So by end of week 8, when Mr. S was leaving us and we were discussing things, and we explained the impact to him, he explained us a concept of zero trust, and he said that's something which is really so important for us because it involves a lot of networking, connection between users and the systems. We should be exploring something called zero trust. And that's how the concept of zero trust CI/CD came to our technical lives. This is the first time we heard about zero trust CI/CD. Okay, so here we are. We started, we understood the system, we found the problems, we found somebody to help us, and by end of week 8, we realized that we need to fix our system by looking into zero trust CI/CD. All right, we have something new. We need to do zero trust CI/CD. When you get something new, the first thing we do, we just do google.com and search for zero trust CI/CD. This is what we did, we all did. But unfortunately, there was no definition. Okay, how to get started then? Google doesn't offer anything. We thought that we need to build our own definition of zero trust CI/CD. And this is how it started. Obviously, while building our own definition, we wanted to make sure that we respect the basic idea of zero trust. So we did enough research from Google to understand what zero trust means before we build our own definition of zero trust CI/CD. So we started the very fundamental concept of zero trust called never trust, always verify. And we said, okay, we're going to do it for our pipeline. The second thing, temporary access token. No long-lived credentials. I'll grant you access, but as soon as you finish, your access is revoked. And then next time, if you connect to my system, you're gonna request access again. Least privilege implementation, only allow you what you need to do, not more than that. Environment segmentation, we're gonna talk about that. Another part, two-factor authentication, something which is pretty basic, but unfortunately we were missing it. And the last thing, do not log PII, personal identifiable information, and sensitive data in the logs. And that's the definition, these 6 things which makes the definition of zero trust CI/CD for us. let's take a closer look on all of these things. So first thing, never trust, always verify. We needed to define, so in our case, we have two systems, GitHub and GCP. We needed to define what GCP should trust. And then we need to tell GitHub that when you connect to GCP, you present your identity and let GCP decide whether it can trust you or not. And then GCP has an option to validate that identity and say, okay, I trust you or I don't trust you. If I trust you, then I'll let you in and I'll let you access the system. If I don't trust you, okay, you step right here. And that has to be done every time a new connection is requested. So we verified your identity once, but we're going to verify it again if you want to access the system next time. Never trust, always verify. Second thing, temporary access token. Let's think of a scenario that I trust you and I allow you access, but how long? How long I can trust you? And that's where, when GCP decide that I trust you, so the answer of this section is yes, then it's only gonna grant GitHub a temporary access to the resources so that GitHub can access things at this moment, but if the next time GitHub wants to connect to GCP, it's gonna repeat the same process again. Then, least privilege implementation. The access that comes through the temporary access token should only grant GitHub access to do things that it's supposed to do, not more than that. So it should only provide access to do the job, that's all. The fourth concept was environment segmentation. That's interesting because we have GitHub, we have GCP. GitHub has its own environments, GCP has its own environment. We do not want GitHub development environment to deploy changes to GCP production environment. You don't want that. You want this. You want GitHub development to connect to GCP development, and same for staging and same for production, but not like that. There's a clear wall, and we wanted to make sure that this happens. So that's environment segmentation. Two-factor authentication, as I said, it was basic, but we were missing it. We wanted to make sure that we check the memory of the users by asking the passwords from them, but also either O2P or the token that they possess, so that it's a two-factor authentication. And the last thing is do not log PII and sensitive data. Things like this, the name of the users, emails, even the tokens, sensitive data, source IP, phone numbers, user ID, or any other thing. We wanted to make sure that we do not log this information into our system. So that's the 6 pieces that we defined as part of Zero Trust, CI/CD. That's a theory. How are we going to implement this? So let's see some technical implementation. It's going to be pretty brief. I'm not going to deep dive into too much, but I'll make sure that I'll give you enough ways to start your own technical implementation. And that's where I'm going to introduce you to OIDC, OpenID Connect, and Workload Identity Federation. It's what it's written here, but in general, what it does, this whole process, let us exchange the short-lived tokens directly from the cloud provider if the trust is set up. If the two systems trust each other, then they can exchange temporary access token and then let one system access resources on another system. I think that's pretty much what we wanted, I think. We wanted a temporary token. We wanted to set up the trust level. So that looks quite interesting. Okay, let's go inside that. How does it work? So that's the workflow. As I said, on the GCP level, we're going to set up the trust level. We're going to define what our cloud provider should trust. It could be GCP or any other cloud provider. We're going to give GitHub an identity. GitHub is going to send that identity to GCP. GCP is going to decide whether it trusts the identity or not. It's like, yes or no, okay, I trust you, I don't trust you. And if it trusts the identity, then it's going to send an access token, again, a temporary access token to GitHub to access the GCP resources. Let's try to look into an extended version of the same workflow. It's pretty much same. The only difference is that in this one, we have something called a service account. And what happens when you have the temporary access token from the past workflow, that access token can be used to impersonate a service account. And that means we can have different service account impersonation, which means different privileges to do different tasks. So as part of this workflow, you will only get permissions that are assigned to this service account, not more than that. And since we can impersonate multiple service accounts, we can have a clear segregation in terms of access. It's like least privilege implementation to access Google Cloud resources. Okay, so we talked about that we're gonna give GitHub an identity. How does this identity look like and how it's gonna help us? Let's look into some very interesting things. So first thing is the repository owner name, environment of the pipeline where you're gonna run the code. The branch and the repository, and also we have GitHub name and the branch of the pipeline. Okay, that's really interesting. So if we set up this workflow, GitHub can provide this information to Google Cloud, telling, okay, this pipeline is running under this repository, this environment. Even it can actually send the name of the workflow, the branch where it is running. So this, everything can be sent to GCP. Okay, and then what GCP can do as part of the trust level that it's gonna set up, it can decide, okay, I only trust a request if it is coming from a repository called invoice within an organization called TWR, from an environment that is development, and from a branch called main, or I can trust somebody whose repository is payment, the branch is development, and the environment is development, and the branch is release. This is pretty interesting, which means now I can filter request. The GCP can filter request based on the environments. It can decide whether it wants to allow connection from the development environment or from staging or from production. It can also decide from which branch it wants to allow connection. You can have a simple condition like this one, just a filter on repository, or you can even have some complex conditions depending on what information you get from the ID token from GitHub. Really interesting. So now it gives more power to Google Cloud to filter what it should allow and what it should not. This is the sample Terraform code that you can do to set up the trust level at GCP end. Most of this code is publicly available on public Terraform registry. It's a module basically by supplying some input parameter, and you really get it set up. And that defines the trust level on the GCP end. On the GitHub end, what we do, in order to create an identity, we use something called a GitHub identity token URL to give GitHub an identity. Once the identity is given to GitHub, GitHub sends that identity to GCP to a service called security token service. And what security token service does, it looks into those conditions, the trust level that we define, and then it filters whether you are allowed or you are not allowed. If you are allowed, then it's going to send back a temporary access token, and then that access token can be exchanged with another token to impersonate the service account. And that's going to give you only the privilege that you need in order to provision or access certain resources. What we see in the last slide was pretty complex because we had to create an identity. We had to send the request to security token service, get the token, send it again. Google simplified for us. And now this can only be done by using a GitHub action that is available like this. You just need to supply a workload identity provider, the trust level that we set up at GCP level, and a service account. And this action knows to do all that, to give GitHub an identity, exchange the temporary access token, and then impersonating the service account. All is done by this action. Okay, so that's the recap. By giving an identity, validating it, and setting the trust level, we implemented never trust, always verify. We also exchange only the temporary access token. So we implemented temporary access token, not long-lived credentials. By using service account impersonation, we implemented least privilege implementation because now we could impersonate different service accounts depending on what access we need. And then, since we have more control on what we want to allow, we also have environment segmentation. We only allow GitHub development environment to connect to GCP development environment. In order to implement two-factor authentication, it was more like a coordination thing that we did. We talked to GitHub organization owner, and we send a notification to everyone in the team that we're going to do it, and then we simply did it. And what it does, it now let users to validate both their passwords and their memory and their possession also, like OTP and token. That wasn't really technical, but we wanted to make sure that we are secure with our users connecting to the GitHub system. Do not lock PII. That was tricky because PII is something that is specific to an organization or a country you are operating in. Every country has its own way to defining personal identifiable information or even the sensitive data. So we spent some time working with the legal team to define PII first before we can actually look into what to prevent. Once we had that, we verified our logs to find out whether we are really logging something or not. One of the trickiest part with PII, we as a developer tend to use a lot of libraries. That's pretty common. And sometimes we try to use some logging libraries who do not define in their documentation that they're going to log PII, but they do. And you really have to be careful with that. Other thing that we did is that we created an architectural decision record so that the kind of implementation that we did and the kind of decision that we took for PII remains in future part of the implementation as well. Okay, so here we are. By end of week 12, we have two happy teams, Team Y and Team G, with a kind of Zero Trust CI/CD implemented. So we have a Zero Trust CI/CD implemented, but we started with a question in the beginning that the systems that we saw in the beginning, were these systems ever secure? And we're going to ask this question again, that even if we implemented this, are we secure? The best part is that now I can answer it, and probably you can also. Security is not something where you can say yes or no. It's all about being an acceptable level of risk. And now we are within an acceptable level. The most interesting thing is that we understand our system. We took some conscious decision from the security. We understand the probability of those issues and their impact. And since we understand them, we are better prepared to handle them. As I started, security is a journey. What we did is just a beginning. We're going to continue. We already introduced threat modeling as part of our sprint. And in every sprint, every change that is going into our system or every new thing that is being introduced into our system, we are measuring it against threat modeling. And we are checking that any new addition or change it should still let us remain within an acceptable level of risk. That's the target. That's the team of engineers, the Thoughtworkers, who actually implemented this Zero Trust CI/CD. That's me on the right. Security is a journey. What I just said probably could be a nice base to get started, but every system is different, every implementation is different, and there are different set of complexity. What I just said, it could be a baseline, but you need to start your own security journey. Probably some things which I explained might help you to drive your security journey, but the chance is that you might have to understand your system better and then decide what fits best to you. But let's get started. Thank you.